Hello children, welcome back. Hope you all are fine. So today we are going to discuss about spherical mirrors. That's what we'll just have an introduction to spherical mirrors and some basic terms related to spherical mirrors, like which we have discussed in our previous video, that is about plane mirrors and basic terms related to plane mirror. So let us see the same thing about spherical mirrors in today's video. So assume that we are having, or you are having, a hollow spherical glass sphere. Hollow spherical glass sphere. So assume it is like this. So hollow spherical glass sphere. So hollow and spherical glass. Glass means it is a transparent substance and it is a hollow. Internally it is empty. And then also we are having a kind of this one spherical one, so which is in the form of a sphere. So now from this I would like to take two parts out of it. I would like to cut two parts out of it straight away. I would like to cut two parts out of it straight away. Say one of the part I would like to consider over here, and the another part from the other side. Okay, see here I would like to just consider the things in this way now. So just imagine how I am trying to do these things. So I just want to take out, imagine a gems ball, children. So you know a gems ball, right? So a gems ball you imagine with a hollow spherical glass sphere. So from that you just remove the opening, the cap of your hollow glass spherical surface. So if you remove that hollow spherical glass surface cap, how it is going to be? So it is going to be a small piece of a spherical surface which is been cut out from a big sphere. So in this way I can just say now, so if I consider the same part, so like this, two parts of this hollow glass sphere I have considered in this manner. See, the two parts I have just taken. So here is one part and the other side is one more part. Hope you understood, right? So I just cut two parts from either side like this. So on closing those two parts will form you again a glass sphere, that is a circular part. So now if I just can do only one thing, that is what I can do, silver the two surfaces. So you can get it out. So silvering can be done on either of the surface, right? So here one is bulged part and one is the inner part. So let us do the same thing. So for one surface you silver the bulged part. See, I am just silvering the bulged part in this way, the outer edge. And for the second surface I am silvering the inner edge. So thus through which this transparent curved parts will be acting as a spherical mirrors. So therefore now this is a reflecting surface. Now this is a reflecting surface for you. And similarly here this is a reflecting surface. So each curved surface is now acting as a mirror because you have done silvering on the either of the side. So thus obtained mirrors are termed as your spherical mirrors. So you need to give the separate notation and the names for each of the things, right? So let us take that one. So if you just pick out of that thing the curved part from that sphere, just imagine it is going to be like this only. So this is your curved part. So therefore I have just taken this one in this way, and now just imagine the part. See here this one. So just silver it. So what you will get on silvering this one, a mirror is obtained in this way. And if I consider one more part which you have cut from this one, so take that one also. So this is the part you have taken from the one more end. So if I just try to silver it on either side, so already we have bulged it, I mean like silvered on the bulged part for the previous one, right? So now inner edge if you bulge it, I mean like silver the inner edge. So the two type of mirrors were obtained here. So the terms of the mirror are given as, this one is your concave mirror and this is termed as your convex mirror. So thus the spherical mirrors are nothing but the mirrors obtained by silvering on either side of a curved surface, either inner edge or the outer edge. So if you silver the outer edge, we get a concave mirror, and if you silver the inner edge, you are going to get a convex mirror. See this one. This is your outer edge. You are just silvering the outer edge, so therefore we get a concave mirror. Silvering the inner edge, you are getting a convex mirror straight away. So now let us learn about these two mirrors in detail with whatever the different kind of terminologies we will be using for this to understand clearly. Okay, shall we do it? Yeah. So let us go now into the topic. So first let us consider a concave mirror and then a convex mirror. For that I would like to take as usual two spheres, hollow glass spheres as we understood right previously. So say this is one hollow glass sphere I just considered in this way over here, and for the next one convex we require right at the same time. So let us take the convex also over here. So two different mirrors I would like to take. So now what did I say previously to you? Cut or take a part out of this one. So if I take a part out of this one, see like this, I can just assume that part on what you call this extending the curvature will form a sphere only. That's what we are assuming right from starting onwards. So this is one part or a spherical mirror you have taken out, and over here I am just assuming once again a spherical mirror to be cut out, right? So let us take this spherical mirror to be cut out in this manner for you. Okay, see here now I have just cut it the outer edge, I mean like this one. So take in two parts out of a hollow glass sphere, and where I would like to silver these edges so that I will get two mirrors, right? So see here this one, silvering the bulged part I obtained concave mirror over here, and for this silvering the inner part I have got obtained the convex mirror. So this is what we have learned till now. So now let us see the basic terms. What are all the basic terms we are going to learn for the spherical mirrors? One after one. As usual, like previous video, I will be just saying, you just try to note it down in your books so that it will be easy for you to recall or understand the things immediately. So the first most term you are going to learn is center of curvature. The first most term you are going to learn is center of curvature. So how to define this center of curvature? See, listen, in this diagram, in both of these diagrams, I can just say that there is a big sphere. From that sphere only you have taken this spherical mirror outside, right? So if I can just have a center for this sphere, see the center for this sphere, glass sphere, and over here similarly this one also, this also has some center, and that you can call the center of this sphere. So what I can say now, define this one center of curvature. The center of the sphere from which a spherical mirror is taken out, or the spherical mirror is a part of it, is called as center of curvature. Once again, see here, the center of the sphere in which spherical mirror is a part, or the center of the sphere in which spherical mirror is taken out, is called as center of curvature. So now I think you understood right now. So when you consider a spherical mirror, if you just extend those edges, it will form a sphere, and this sphere ka center we call it as a center of curvature. So this is what your first thing. And next, second definition, or second term we are going to learn is radius of curvature. The second one you are going to learn is radius of curvature r. So as usual, replace the center, the word center by radius. So what you will be getting this one like this. See here, the radius of the sphere. See this one, the radius of the sphere in which the spherical mirror is a part, or the radius of the sphere in which the spherical mirror is taken out is called as radius of curvature directly. And the third one you are going to learn is pole and is denoted by P. So what was this pole, sir? See here, you have seen a one center for the center of the sphere, right, in which spherical mirror is taken out. So imagine the James ball once again. The cap of the James ball has a center at that center, right? The midpoint one. See, it means for every spherical mirror has its own center. This one. On the spherical mirror, the center. So what we call this one as geometrical center. What we call this one as geometrical center of spherical mirror is called as your pole. The geometrical center of a spherical mirror is termed as your pole straight away. So now there are two centers you have seen. One center is of your sphere ka, second center is for your spherical mirror. So whatever the sphere's center will be termed it as center of curvature, and then mirrors, spherical mirrors center is termed as pole. So please don't get confused with these terms, right? And the fourth one, principal axis. And the fourth one is principal axis. So just imagine over here only. So if we draw a line, or you can say imaginary line passing through pole and the center of curvature. If you take an imaginary line passing through pole and center of curvature, and such a line we call it as principal axis. And such a line we call it as a principal axis. So a line drawn or an imaginary line passing through pole as well as center of curvature, we call it as your principal axis. So this is one thing. And next, fifth, normal. So okay, listen children here, for easy to understand, I would like to just now erase these what you call the sphere patterns, so that it will be easy for us the further the diagram to be understood carefully. So therefore, I would like to erase this one, and I will show you the radius of curvature on the other side. So I am just taking out this one. So now this seems to be like a mirror for you now. So I am just leaving that part. I will just what you call, so that radius of curvature I can show it on the other side for you later on after the explanation. So I think you can understand that, right? The presence of r over there, which shows you this what you call this radius of curvature. So just leave it like that. I will just erase it and I will just show you on the other direction later on. So now this is the diagram, we just got it. Now what we are going to learn it is about normal. Okay, see here, normal is nothing but, simply just assume there is a point on the spherical mirror where the light is going to get incident. There is a point on the spherical mirror where the light is going to get incident, and that point we call it as point of incidence. Very well known for us, that one. So now if I draw a line, passing through center of curvature, and any point on the spherical mirror, So what do you mean by any point on the spherical mirror? I can say that one as your point of incidence. So this is called as your normal. And similarly here also, any line drawn or a line drawn through center of curvature and any point on the spherical mirror is called as your normal. So therefore this line is defined as your normal. That's it. And next, most important definition we are going to learn is focus. Focus. And this is given by F. And now see here, focus, how to understand. So let us imagine, as you have already taken this one, what you call this point of incidence, right? So I would like to draw a line coming parallel to the principal axis. I would like to draw a line coming parallel to principal axis, and that too incident on this point here, on the spherical mirror. See, like this. And similarly for this one also, I would like to take a light ray passing parallel to principal axis and incident on the spherical mirror in this way. So what you will do based on your knowledge, so we will measure angle of incidence over here, and at the same time we will be measuring angle of incidence, and then we will calculate angle of reflection. After finding angle of reflection, that is what we will say, I is equal to R. And here also we know that I is equal to R. Angle of incidence is equal to angle of reflection. So if in such pattern, if you draw an angle of, like reflected ray, taking an angle of reflection as R, which is I is equal to R. And similarly over here also, if you draw a reflected ray and taking the angle of reflection as R, and such that I is equal to R. In this way, if you just consider the things, and not only one reflected ray or one incident ray, I would like to take one more incident ray also. See here, a parallel incident ray, one more. So I would like to consider in this way, and similarly here also a one more parallel incident ray, and again these also reflect back, such that the reflected rays are meeting at a point on the principal axis here. And for this one though, so what I can do, just only one thing, the reflected ray previous one is not at all meeting, so therefore what I can do, I can just extend it behind. And similarly this reflected ray also will be extended behind, so therefore the reflected ray is to be considered in this way. And on extension, the two reflected rays on extension meet on a principal axis at this particular point, and such a point we term it as focus, or we term it as focal point or principal focus. So how to define this one now? So I can say directly, see here, the point on the principal axis where the reflected rays of parallel incident beam, once again, the point on the principal axis where the reflected rays of parallel incident beam. See here, this one also, the point on the principal axis where the reflected rays of parallel incident beam directly meet or appear to diverge from focus, or appear to diverge from focus, or from a point, or appear to diverge from that point, and that point we call it as focus or principal focus. See once again, the point on the principal axis where reflected rays of parallel incident beam directly meet or appear to diverge is called as focus or focal point or principal focus. That's it. And the last but not the least one, we can say there are more, but we will end up over here. Seventh one is focal length. Focal length. So therefore it is denoted by small f. So in the diagram, the focal length is denoted by small f. Over here, this one, see this. So this is your focal length, and that is defined as the distance between pole and principal focus. The distance between pole and principal focus is focal length. The distance between pole and focus is defined as a focal length. So taking into consideration of this definition, I would like to alter the definition of radius of curvature also once again. So I can say one more definition, that is the distance between pole and center of curvature is also termed as radius of curvature. See this one. pole to center of curvature is also termed as radius of curvature. So the distance between pole to center of curvature is radius of curvature, pole to focus is focal length. So these are the terms, some few basic terms related to your spherical mirrors. Hope you all understood, children. So in the next topic we will just learn about how to draw the ray diagrams, and that are rules to draw ray diagrams for both concave mirror as well as convex mirror. Thank you all of you. Have a great day.